Homework 92-2D, number 25. This one was requested, having some difficulty with it. This is a little bit different than what we had in the notes, so kind of understandable. A 1345 kilogram car moving east at 15.7 meters per second is struck by a 1923 kilogram car moving north. They are stuck together and move with an initial velocity of 14.5 meters per second at theta equal to 63.5 degrees. Was the north moving car exceeding the 20.1 meter per second speed limit? So we start this out seeing that right here we have car A that is moving to the right at 15.7 meters per second. That's east. It has a mass of 1345 kilograms. So we know everything about car A. Car B has a mass of 1923 kilograms, but the only thing we know about its velocity is that it is moving north. Which means that after they collide, they stick together, and they move up at an angle of 63.5 degrees and a velocity of 14.5 meters per second. Now, other information that I'm going to need later. Since they collided and stuck together, I'm going to use this information that the mass of both combined, 1345 kilograms of car A plus the 1923 kilograms of car B, is equal to 3268 kilograms. The combined momentum is actually going to be 3268 kilograms times 14.5 meters per second. I know the mass and velocity of them when they're stuck together, which gives me a total of 47,386 kilograms times meters per second. Now, setting up our table, similar to what we've done with all these other problems, we have PA, PB, and then PAB for our rows, the momentum of car A and car B before the collision, and then the momentum of cars A and B combined after the collision. And we have the X and Y direction for our columns as we have before. Looking at car A specifically, it was traveling at 15.7 meters per second with a mass of 1345. We multiply those two together to get 21,116.5 kilograms times meters per second in the X direction. It was only moving the X direction and had zero velocity in the Y direction, so momentum in the Y direction is also zero. For car B in the X direction, we don't know what velocity it was going overall, but we know it was going straight north. Going straight north meant that it had no velocity in the X direction, therefore no momentum in the X direction. For the Y direction, we don't know the velocity for car B. It's what we're trying to determine, but we do know that the momentum in the Y direction will be the mass of the car B, 1,923 times VB, which is the velocity of car B. Now, we have the same kind of situation where to fill in AB, we take that momentum that we had found up here for A and B stuck together, 47,386, and multiply it by cosine of 63.5 for the X direction and sine of 63.5 for the Y direction. We actually don't need the X direction to solve the rest of this problem, but it's already there, and we're used to filling in a table if we have the table. All we have to do to solve this problem now is remembering our conservation of momentum, and that the total momentum in the Y direction before the collision, which would be 0 plus 1923 times VB, is equal to the total momentum after the collision, 42,407.3596589. So I take that 42,407.3596589 kilograms times meters per second, and that is equal to 1923 kilograms times VB, which was the momentum of car B in the Y direction, plus 0 kilograms times meters per second, which was the momentum of car A in the Y direction. Solving for VB only requires me to take 42,407.3596589 and divide by 1,923. This gives me an answer of 22.052709 meters per second. Normally at this point we would end up rounding for significant figures. However, this problem didn't ask us to find the velocity. It simply asked us if the car traveling in the northern direction was speeding or not. So all we have to do to answer the question is say yes, because 22.05 is greater than 20.1.